So now we are going to start 24th problem, which is from 1998 AIPMT. In a photoemissive cell with exciting wavelength is lambda, the fastest electron has speed v. If the exciting wavelength is changed to 3 lambda by 4, the speed of the fastest emitted electron. See what you are doing. Initially, you are sending a photo cell of wavelength towards a photocell, a wavelength of light lambda. What you will get? You will get kinetic energy of ejected electron phi minus phi naught. Phi naught is hc by lambda. It was hc by lambda. With exciting wavelength is lambda. It is, you are sending a light hc by lambda. One part is used as a work function, second is giving it kinetic energy. Now what you are doing? You are increasing the input by decreasing the wavelength. Now you are using the light of wavelength 3 lambda by 4 means 4 by 3 this, but this part is same. Suppose you are sending 10 electron volt energy. It is spending, you are sending 9 electron volt using as a work function, suppose 3 electron volt. With kinetic energy, it will use 6 as kinetic energy if it is work function. If you are sending now 4 by 3 of it, 4 by 3 of it means 12 electron volt. 3 will use in this. What is remaining? Now remaining is 9. What is the 4 by 3 of 6? 4 by 3 of 6 is 8. Means you are getting, if you are increasing the energy by 4 by 3, kinetic energy will increase by more factor than 4 by 3. So we will go with option D. We will go with option D. You are increasing the input by 4 by 3 of previous value. So I give you this example. Since work function is constant, so energy received by electron as a kinetic energy, it should be more than 4 by 3. Since it is, we want to talk about V square, so V square should be greater than the previous values 4 by 3. So V should be greater than V into root of 4 by 3. So we will go with option D. Next, it is from 1999 AIPMT. The photoelectric work function for a metal surface is 4.125 electron volt. We want cutoff wavelength. We know that work function is hc by lambda naught. So lambda naught should be hc by phi naught. First we will do in SI units. What is h? 6.63. 10 to the power 9 minus 34 joule second. What is c? 3 into 10 to the power 8. What is phi naught? 4.125 electron volt multiplied by charge of electron. You will get in joules, so we are getting this in meter. But options are in angstrom. Means we have to multiply by 10 to the power 10. We have to multiply it by 10 to the power 10. Now answer is in angstrom. So what is the 10 raised to the power? It is 10 to the power minus 19, it will become plus 19. 19 and 10, 29 and 8, 37, plus 37 minus 34. So it means plus 3 number. So we will calculate it by calculator to save your time, to save our time. What are the number? 6.63 into 3 divided by 4.125, again divided by 1.6. What we are getting? We are getting 3.01. So 3.01 into 10 to the power 3 means nearly 3000 angstrom. So we will go with option A. We will go with option A. Next, it is from 2000 AIPMT. By photoelectric effect, Einstein proved. You know that what was photoelectric effect? Einstein proved that photons are behaving like an particle and energy of photon is given by h into nu. But one formula for nu E was mc square. So when he equated both, he got the momentum of light. Nu means c by lambda. He got the momentum of photon. Next, 2002 AIPMT, just they are asking the value of Planck's constant. We use in so many problems. 6.63 into 10 to the power minus 34 joule second. Next, according to Einstein's photoelectric effect, the graph between the kinetic energy of photoelectrons ejected and the frequency of incident light. We know that it is, they asked this in 2004 and 1996 AIPMT. If we are increasing the frequency, kinetic energy will increase. So reject the option number A. It will not decrease with increase in frequency. When frequency is 0, electron will not eject. B, cancel B. After, when you are increasing the frequency, after crossing a certain limit, what we are getting? After crossing a certain limit, which is known as threshold frequency, only then you will get kinetic energy. It will start after a certain value. So we are going with option D. Next, it is from 2005 AIPMT. A photosensitive metallic surface has work function h nu naught, and you send photon of energy to h nu naught. Electrons come with maximum velocity of 4 into 10 to the power 6 meter per second. When you increase the photon energy up to limit 5 h nu naught, what is the maximum velocity of photoelectrons? So what happened initially? You send a photon of 2 h nu naught. Metal spent this part in taking electron out of the surface. So kinetic energy was due to this h nu naught. It gave kinetic energy to electron and he got one velocity v. What you are doing now? Now you are sending a photon of 5 h nu naught. Again metal is same, it will use h nu naught to come up to surface. Now 4 h nu naught will supply kinetic energy. Electron is same but velocity will increase, so I am denoting by now v1 square. So what we are getting, dividing second equation by first, we are getting v1 square by v square, means v1 should be equal to twice the previous value. Previous value was 4 into 10 to the power 6 meter per second. So now it should be 8 into 10 to the power 6 meter per second. So we are going with option D. Next, they asked in 2005 the work function for metal A and B and C are given. What they gave? For A, if you want photoelectric effect, minimum energy you have to send towards metal should be this electron volt. If you want to see photoelectric effect in B, minimum energy you have to send 2 electron volt. It is the meaning of work function. For C, it is 5 electron volt. Now you are sending a photon of wavelength 4100 angstrom. What is the energy of this photon in electron volt? First we will calculate that. Phi is hc by lambda. First we will calculate in joule. C 3 into 10 to the power 8 divided by lambda. It is 4100 angstrom, means this meter. Now we are converting this into joule by dividing the electronic charge. It is in joule. We want to convert in electron volt. Now it is in electron volt. Number involved are 6.63 into 3 divided by 41 into 1.6 and 10 to the power minus 10 and minus 19. It is minus 29 plus 8. It is 37. Means it will become 3. Means 6630 into 3 by, oh, 2 zeros are this. So 2 zeros are this. So it will become minus 29. 2 zeros are the 2 zeros, minus 10 and minus 19. So they are minus 27. They will become plus 27 and 8, 35. So we will get only 110. So what we are getting? 66.3 into 3 divided by 41 into 1.6 means 9 16 ones are 16, 16 fours are 64 and 165. Remove the decimal. Nearly 3 electron volt. It is more than the work function of A and B, but less than of C. So it can eject electrons from A and B. So we will go with option B. Next, it is from 2006 when photon of energy h nu fall on an aluminium plate of work function E naught. Photoelectrons of maximum kinetic energy K are ejected. If the frequency of the radiation is doubled, the maximum kinetic energy of ejected photoelectrons will be. What was happening initially? You are sending a photoelectron of energy h nu. Work function was E naught and ejected electrons kinetic energy was K. Now you doubled the energy. Frequency means you are doubling the energy of radiant photon, so it will become 2h nu. E naught is same. Now suppose kinetic energy is K dash. Subtracting first equation from second, what we are getting? H nu is equals to K dash minus K. So what is K dash now? K plus H nu. So we will go with option B, 31st B. Next, it is from 2008 AIPMT. The work function of a surface of a photosensitive material is 6.2 electron volt. The wavelength of the incident radiation for which the stopping potential is 5 volt lies in the. What is stopping potential? Stopping potential means if electrons are coming out with some energy, you can convert this energy into electron volt. Suppose electron is coming with 5 electron volt energy. If you apply a 5 volt negative voltage, it will cancel the energy of electron and you can stop the electron as it is. Means it was on surface, it will not come out from surface because you pushed back by same energy. So that voltage is known as electron stopping potential. Means if you want to calculate stopping potential, calculate the maximum kinetic energy of electron in electron volt and remove the word electron, you will get stopping potential. Suppose electron is coming out of the metal surface with energy 10 electron volt. Remove electron means stopping potential is 10 volt. If you apply 10 volt negative voltage, it will not come out. Getting my point? So what they are saying, कि minimum energy required to eject an electron from a metal is 6.2 electron volt and you are sending a photon of energy phi. And work function is 6.2. Stopping potential is 5 volt. It means electron is coming out with energy 5 electron volt. It means you sent a photon of 11.2 electron volt energy. But energy is represented by H into nu. So you can calculate the H. First convert this into SI unit by putting the value of electronic charge. Now it is in joule. So frequency of this radiation is H, means 6.63 into 10 to the power minus 34 hertz. Yes, now we can use calculator to save our time for this calculation. Zeros we will collect. Numbers are 11.2 multiplied by 1.6 divided by 6.63. So we are getting 2.7 into 10 to the power. Take minus 34 in numerator, you will get plus 34. 34 minus 19, it is 15 hertz. And we know that the range of frequency of X-rays, it is from 8 to 10 to the power 14 hertz to 10 to the power 17 hertz. So this photon will lie in X-ray region. Next, the figure shows a plot of photocurrent versus anode potential for a photosensitive surface for three different radiations. Which one of the following is a correct statement? Retarding potential, you can see that retarding potential for B and A, it is same, means from B and A electrons are coming with same kinetic energy, so that to stop them we need same retarding potential, means stopping potential. For curve A and B, and kinetic energy depends upon frequency. So we can say curves A and B represent incident radiation of same frequency but of different intensities, because photocurrent is different, means intensities are different. So we will go with option B, 33B. 34. The energy of a photon of wavelength L lambda is, we know what is energy. Energy is hc by lambda. So we will go with option C, direct formula they were asking from you. 1990 AIPMT. A radio transmitter operates at a frequency of 880 kilohertz and a power of this. The number of photons emitted per second are. What is the energy of one photon? First we will calculate that. One photon energy is equals to, energy means h nu, h you know, frequency they give 880 kilohertz. So what we are getting, 6.63 into 88, 6.63 into 88 means 58,344. 10 is already there. 88 into 6.34. 88 into 6.34, we are getting 557.92 into 10 to the power 10, it is 1 and 3 4 zeros, so we are getting minus 30 joule. Suppose n photons are coming out in 1 second. Let n electrons are emitted per second. It means energy per second. This implies energy per second we are getting from source is equals to n into energy per second means power. Therefore, power of source, it should be n into 557.92 into 10 to the power minus 30 watt minus 30 watt. But they are saying power is 10 kilowatt. So what is given? It should be equal to 10 kilowatt. N into 557.92 10 to the power minus 30, it should be 10 kilo means 1000 watt. So now we get the number n. 10 to the power 4 divided by 557.92, 10 to the power minus 30, take in numerator, it will become plus 30. So what we are getting now, take, it is 557, take 2 zeros with 10, it will become 1000. 1000 into 10, so we can write 10 to the power 4, 1000 into 10, this upon 557, so less than 2 and power is 31, so we will go with option A. So what we are getting? A option. Next, a wavelength of a 1 kilo electron volt photon is this. What is the frequency of 1 mega electron volt? What we know? We need frequency of 1 mega electron volt photon. Energy is h into nu. Energy they are saying 1 mega, mega means 10 to the power 6. Electron volt means this joule. Photon's energy is this, but energy is h into nu. So no need what they gave wavelength for 1 keV. We didn't need that number. So directly we can calculate by this. Frequency is equals to 1.6 10 to the power minus 13 divided by 6.63 into 10 to the power minus 34. Take minus 34 in numerator, become plus 34. 34 minus 13, it is 21. Take 1 0 with 16. 16 into 10 to the power 20 divided by 6.63. 6.633, it will cross 19. Means 2 point something into 10 to the power 20. Only one option is there, so we are going with B. Next, momentum of a photon of wavelength lambda. We know that energy is mc square, but energy is h into nu. Momentum is mass into velocity. Take 1c on that side. So what is the momentum of photon? H nu by c. So we can go with option A. 38. the minimum wavelength of the X-ray produced by electron accelerated through a potential difference of V volt is directly proportional to what we knows that energy is hc by lambda. But energy is charge into potential difference, electronic charge into potential difference, hc by lambda. Hc and E are constant, so you can see lambda is inversely proportional to V. So we are going with option B, 38B. 39th, they asked in 1996 AIPMT, if a photon has velocity c and frequency nu, then which of the following expression is wavelength? What you know, h nu is hc by lambda. H nu is energy. You can say hc by lambda. So what is lambda? Lambda you can calculate. H nu is not wavelength, it is energy. Hc by lambda. So lambda is hc by h nu. Means c by nu we can write. Hc is energy, h nu is energy. So we can write this as c nu by lambda. Velocity is yes. We can write this. V is equals to n lambda. N lambda. And h nu is energy. Energy will cancel with energy. Yes, we got the wavelength in C. Next, it is from 1997 AIPMT. The kinetic energy of an electron which is accelerated in the potential difference of 100 volts. We know that charge into potential difference is energy. So energy should be E into V. Charge of electron 1.6 10 to the power minus 19. Accelerated by voltage 100 volt. So in joule we are getting 1.6 into 100 into 10 to the power minus 19. So we are getting 1.6 into 10 to the power minus 17 joule. So we will go with option C, 40C. 41st, it is from 1999 AIPMT. When a proton is accelerated through 1 volt, again same thing, charge into potential difference is energy, and proton has same charge which electron has. So 1 eV it will get as kinetic energy. So we will go with A. 1989, the de Broglie wavelength corresponding to a particle of mass m moving with velocity v has a wavelength associated with. What was de Broglie's idea? कि a photon has energy mc square, and second form of this formula should be hc by lambda. Since it was energy of photon, m should be mass of photon. So mass into speed means momentum. So wavelength should associated with any particle should be Planck's constant upon momentum. So h upon mv will give you wavelength. So we are going with option A. 1995 AIPMT. If we consider electron and photon of same wavelength, then they will have same. You know that energy is hc by lambda. H and c are constant for all particles. So we will go with C. 2002 AIPMT. If particles are moving with same velocity, then which has maximum de Broglie wavelength? What I told you, de Broglie wavelength is given by h upon momentum mass into velocity. velocity is same. For maximum of lambda, m should be minimum. So lightest particle in this 4 is beta particle electron. So we will go with option D. Next, it is from 2008 AIPMT. A particle of mass 1 milligram has the same wavelength as an electron moving with a velocity of 3 into 10 to the power 6 meter per second. The velocity of the particle is, what they are saying, a particle of mass 1 milligram has the same wavelength. What is the formula for de Broglie wavelength? H upon momentum. For first lambda 1, mass was 1 milligram. 1 milligram means 10 to the power minus 6 kilogram. Particle 2, velocity I took this. Electron, mass of electron is nearly 9 into 10 to the power minus 31 kg and velocity is 3 into 10 to the power 6. What they are saying? Lambda 1 is equals to lambda 2. Oh, mass was given. So we should take 9.1. So what is given now? H upon 10 to the power minus 6V. It should be equal to H upon 9 into 10 to the power minus 31 and 6 minus 25 into 3. So what we are getting? V is equals to 9 into 10 to the power minus 25 into 3 divided by 10 to the power minus 6 means 27 into 10 to the power 25 minus 6 minus 19, or you can write 2.7 into 10, so it will become minus 18 meter per second. So 2.7 10 to the power minus 18, so we are going with option C. So in this way we have completed the unit dual nature of matter and radiation. Unit was small, but unit was very, very important. Thank you.